Okay, teammates, before starting any practice today, I want you to watch how I follow our steps of coding a word problem in order to write an algebraic expression. These are the two exit ticket questions from Friday, so this is also an opportunity to just ask yourself, how did you do? And clear up any misconceptions that you might have. So, step one is to read my whole word problem and code my word problem for what I know already and what I don't know yet. So, this word problem says Sebastian has 12 more trophies than Megan. Megan has T trophies. Write an expression that represents how many trophies Sebastian has. Okay, so my first step is coding for what I know already. Well, I know that Sebastian has 12 more trophies than Megan. So I'm going to code this by underlining it. You could code that however you want to. So if you want to underline it, if you want to circle it, as long as you are marking it in a way that you know that it's information that you already were provided with. Okay, what I don't know here is how many trophies that Megan has. It tells me that she has T trophies, but that's not a real value. So this is clearly something that I don't know and that I need to use a variable for. So I'm going to just highlight this piece of information or lack of information, really. Okay, so now I've coded what I know already and what I don't know in two different ways. Now I need to identify the variable. This problem makes it a little bit easier to do that just because it already tells me how many trophies Megan has in variable form. So when it says Megan has T trophies, that T is a variable which is in place of how many trophies she truly has. So it's just holding the place of the number. So if I want to figure out how many trophies Sebastian has, I have to, one, identify my variable, and two, write an expression using my variable. It says that Megan has T trophies, so I'm going to write that in my expression, T. And then it says that Sebastian has 12 more trophies than Megan. Okay, so if he has 12 more trophies than Megan, that means I would have to add 12 to Megan's amount of trophies to figure out how many trophies Sebastian has. So I can write that expression like this, T plus 12. And that is the answer to this problem. Let's move on to number two. Number two says Susie ran a race. She ran 5 miles an hour, and the race took her T hours to complete. Write an expression that represents how long the race was. Okay, so I was given this piece of information that says that Susie ran 5 miles an hour. So I'm going to code that as something that I already know. And then it says that it took her T hours to complete the race. Well, it provided me with a variable, which is great, but it did not tell me how long it took her to complete this race or how many hours it took her. So that's really a piece of information that I don't know yet. So I'm going to code that in a different way. So I'll highlight that. Okay, so next step is to identify the variable. Well, once again, this one does provide our variable for us in place of this unknown number. So since we don't know how many hours it took Susie to complete the race, it provided us with this variable, or letter T. Okay, so I'm just going to write T in my expression and then keep reading to figure out what I'm really being asked for and how to finish up this expression. So it says, write an expression that represents how long the race was. Okay, that's a great question. Maybe this race was 1 mile long, or maybe it was 5 miles long, or maybe it was longer. So, in order to figure out how long this race was, I would have to take Susie's total hours that it took her to complete the race, which is T, and I would have to divide that total time by her speed that she went each hour. Well, I know that she went 5 miles per hour, so I'm going to take t and divide it by 5. So now my expression is t divided by 5, or the amount of hours that it took her to complete divided by her speed, in order to figure out how long this race was. Now you can stop this video and continue on to your own independent practice.